everyone? Am I audible? Yes, good. Okay, hopefully everybody enjoyed their vacation. Yes, now back to pavilion studies. Yes, a very good. Good afternoon to all of you. Okay, I think we I think we have finished off chemical bonding, if I'm not wrong. Yeah. Yes, huh? So in this test, you already know what will be the syllabus, right? Yeah. So hopefully now we are going to start off with the organic chemistry. Yes, organic chemistry. So all of you just put the heading as organic chemistry. So in case of organic chemistry, basically whatever we are going to learn now, that is going to give you a very good foundation as you progress through the entire course, right? Now, when it comes to organic chemistry, basically, now without any further delay, let me just start off with this chapter. Now, when it comes to, if I ask you, like, how do you define organic chemistry? How do you define it? Yes, many of you might say that basically it is the study of carbon, right? Or else we might say that basically it is study of hydrocarbon and their derivatives. That's what is organic chemistry. Okay. So when I say that suppose I'm having a hydrocarbon, you must, kind of catch the word from the kind of, it's like you try to derive the meaning from that itself. When I say hydrocarbon, it is having hydrogen and it is having carbon. So that's what I've written here, a simple hydrocarbon here. Now, when I say that one of the hydrogen will be replaced by some other group, CH3, CH2G. So this has become a derivative of this particular hydrocarbon, right? This G could be any halogen or else OH or any other functional group I can attach, and its property is going to change, okay? So in the simple words, what we can say is organic chemistry is nothing but it is the study of hydrocarbons and their derivatives. Now, you must think about why basically even people thought of a separate stream, to read about hydrocarbon and its compounds, basically why the derivatives has to be read. Now, the thing is, if you will be really shocked to know that the percentage of carbon in the atmosphere and earth crust all together, it's just 0.05%, and it is very, very less, right? But still, we have got millions of compounds, like millions and millions of carbon and its compounds, and basically we are not able to imagine our life without them. That much important it has become with our life, right? We cannot stay away from polymers these days, right? And polymers are unique, like integral part of our life, okay? So basically, whether you talk about medicine or any other kind of application, organic chemistry definitely will be there, right? So if at all percentage of carbon is only this much, this less, still it is able to basically, form millions and millions of compounds. So there has to be certain unique characteristic of this carbon, because of which we are supposed to read this organic chemistry as entire subject. Okay, so let us write down the definition for this organic chemistry, right? So the definition is the branch of chemistry, that deals with study of hydrocarbon and its derivatives, right? So this is basically the hydrocarbon and this is the derivative of that hydrocarbon. So it could be anything, like G could be X, it could be OH, it could be anything, right? Now, reason for forming so many compounds, there has to be certain unique property about carbon, which is basically catenation, which you already know. because we have learned this from, back from standard 8, 9th, like that. So what is catenation basically? This is the unique self-linking property of this carbon. Self-linking means carbon can connect with other carbon, right? It could form a very long chain, or else it could form a ring, or else it could form some branch chain, right? And because of that, we are having so many different types of compounds, right? So I'm going to write that the self-linking property of carbon to form long chains, branched chains, or cyclic compounds, right? That's what is catenation. So first you write up to this and then we'll proceed further. Once you are done, let me know. Now this is what I mean by catenation property. Like carbon is, able to form such long chains. Even I have shown just few carbon atoms chain, right? It can have like something like branching like this could be there. It could also have like branching here also, here also. So several branching is possible. It can also form ring-like structure. This is three-membered ring symbol which I have told you. Now, what is the reason behind this unique property of catenation, which is shown very nicely by this carbon? What is the reason? If you remember, carbon is the first member of its group 14. So it will be smaller in size, right? So if it is smaller in size, then basically it will be able to form bonds nicely, right? Because attraction will be more there, right? So more stronger bond, more strength of the bond is there, right? And apart from that, basically we know, we have already learned about carbon that it is tetravalent in nature. When I say the word tetravalent, that means it can form basically 4 bonds, right? So because of that only it can form, network like structure like diamond will be there, and there are many other different compounds which can exist. So let us write down the reason for catenation. First one is small size of carbon. Second one is tetravalency of carbon. And the next one, we are having basically strong bond. Or else it can form multiple bonds. And we know that there is like C double bond C, C triple bond C, C triple bond N, C double bond O, right? So it can form multiple bond not only with its own atom, it can also form with the other atoms also, like oxygen, nitrogen, and preferably of the second period, right? So it can form multiple bonds with itself and the other atoms. So because of this uniqueness which is shown by this carbon, it is able to show this property catenation. It is able to self-link and give us millions and millions of compounds, because of which we have to study this organic chemistry as a separate branch. Finish writing this. Done? Okay. Now let us go for, there are certain things we have already learned in, chemical bonding. So just like that, I'll be mentioning few things here, and which in detail you already know about it. Okay. Now when it comes to hybridization, so in this case, we need not go for, beyond sp3. We just can be like sp, sp2 and sp3. That is more than sufficient for us, right? So in this case, we are having sp, we are having sp2, and we are having sp3. Now, basically hybridization we'll be calculating using what? Steric number method here, because we know how to draw the structures now. For organic molecules, we know, right? So basically, hybridization is given by what? Steric number. So hybridization is given by steric number, and you are having this steric number. What is that steric number? It is the number of sigma bonds made by the central atom plus the number of lone pair of electrons present on the central atom. So you should be like, kind of capable enough to count this sigma bond, and I'm hoping that you will be like capable enough now because you already have studied chemical bonding, right? So if at all I'm writing something like this, CH3, CH double bond CH, C triple bond CH. In this case, how many sigma bonds are there? 4. So I'll say that the steric number is 4. Basically, I'm not writing all those things now because I assume that you already know, right? Or else if somebody wants it, let me write it. Steric number and hybridization. If it is 2, it is sp. If it is 3, it is sp2. If it is 4, it is sp3. Right? Now in this case, it is sp3. Here it is going to be sp2 because 3 sigma bond. Double bond means 1 sigma 1 pi. Triple bond means 1 sigma 2 pi. Okay. This is also how many around this sigma bond? 1, 2, 3. So it is sp2. This is sp hybridized. This is also sp hybridized because what I am having is 2 sigma bonds here around each of these 2 carbons. Please write this. I'll give you to find out the hybridization, few hybridization here. Of each carbon you find out. Then we'll match the answer. So basically here all of them, they are sp2 hybridized. Hydrogen will not be shown. That has to be understood, right? Because you are able to see carbon is making how many bonds? 1, 2 and this pi bond is also covalent bond, right? So basically hydrogen will not be shown here. So you need to understand that it exists. So all are sp2 hybridized. This one is sp hybridized. This is sp2. All carbons in the ring are sp2 hybridized. Right, all of them, they are sp2 hybridized. Okay. Now certain points about this sp, sp2 and sp3. What is the bond angle here? It will be 180 degree, 120 degree. This is 109.5 degree, or else we write this as 109 degree 28 minutes. Right? And then basically you are having like geometry here. So basically it is going to be linear. Here it is going to be trigonal planar. And here it is going to be tetrahedral. Now if at all we talk about percentage S character. So percentage S means out of S and P there is 2. So 1 out of that is S. So 1 by 2 into 100. So you are having 50%. This is 33% approximately. And this is basically 25%. Similarly, percentage P character also we can write. These are all very simple things, but we are just, kind of revisiting them. So 50, 67%, this is 75%, right? So make sure that you are writing them. Yes, are we done writing? Okay. Now let us move on towards certain important terms. So in those important terms, like all those are basics which we know, right? So the first one, let us look for, basically let us go for molecular formula, or else before going for molecular formula, let us go for what do we mean by saturated compound. Saturated compound means what? There should not be any unsaturation. Unsaturation will relate to the existence of pi bond, right? So basically here I am saying saturated compound means the valency of all the elements are satisfied by sigma covalent bond. Then it is a saturated compound, right? So we can write the compound in which valencies of all the elements are satisfied by sigma covalent bond. That is saturated compound. Like in this case, suppose if I go like this is a saturated compound. You are not able to see a pi bond here, right? That's what is saturated compound. Then you are having unsaturated compound. So unsaturated compound, basically you are having a pi bond there, right? At least one pi bond must be present. That's what is unsaturated compound. The compound which contains one or more pi bond, right? Like you are having this, suppose I write like this, CH double bond CH2, you are having unsaturation here, a double bond is there, unsaturated compound. Please write this out. And once we are done, let me know. Hopefully all of you are able to understand the handwriting over there. Okay. Now next is molecular formula. What is a molecular formula? Basically molecular formula, suppose if I write something like C6H12. So it is telling me basically in this one molecule, there are 6 atoms of this element carbon and there are 12 atoms of this element hydrogen. So that's what is the information which is being conveyed by your molecular formula over here, right? So basically we can write, it gives information about the number of atoms, of each element present in a given molecule. That's what is the meaning of molecular formula, right? Next we are having structural formula. So as the name suggests, structural formula means formula which is representing something about the structure. That means in the structure we'll be able to know how the things are connected, or else how the atoms are connected by covalent bonds with respect to each other. That covalent bond could be sigma, it could be pi, na? So the kind of covalent linkage which exists between different atoms in a molecule is given by structural formula, right? So we are going to write down, it gives information about the type of covalent linkage present between different atoms in a molecule. Now your structural formula can also be like expanded structural formula, condensed structural formula, or else you can have basically bond line structural formula, right? So I'm writing here their expansion, which is expanded structural formula, condensed structural formula, and we are having bond line structural formula, right? So first write this much and then we'll proceed, because understanding this is important. Yes, able to understand? Able to follow up to this? Everybody? Good. Now let us try to understand these things with the help of few examples. Suppose if I take one example as C3H8. So if at all I have to write down the expanded structural formula, so I need to, kind of write it in like entire, all the bonds should be visible. You're able to see C3H8. All the bonds between, like, carbon is single bonded to another carbon, it is also single bonded to hydrogen. There are total 8 hydrogens which you are able to see, 3 carbons you are able to see, right? So that's what is expanded structural formula, expanded, everything expanded. Now if at all I want to write down the condensed structural formula, either I can write like this CH3, CH2, CH3, or else I can also write like CH3, CH2 without showing the connectivity also. This means the same. It has been condensed. I have condensed this. I have written CH3, CH2, CH3, right? Now, when it comes to bond line structural formula, basically I'll be able to draw a zigzag. I could have drawn like this also, or like this also. And we will not be showing hydrogen here. If at all any heteroatom is there later on, we can show that. But we do not explicitly show hydrogen. Getting it? Now the thing is, this has certain significance that here it is sp3 hybridized. So basically it will be representing, like if at all I show hydrogen, so it will be representing that 109.5 degree, right? That's the utility, or else that is the significance of it. As such, hydrogen will not be shown. This is only to make you understand. Okay. Now, suppose if I write C4H10. So if at all I have to write down expanded structural formula, it is quite simple. I can simply, kind of just show all of this bond which is present. This is expanded. And this bond line notation has come to, save on time. When we are writing, maybe some lazy scientist rediscovered it. Because to save on time, every time you're writing expanded, it takes lots of time. Okay. So here you are having condensed structural formula. Either I can write CH3, CH2, CH3, or else I can write CH3, CH2, CH2, CH3. I have removed this bond also. Or else sometimes it could be also written like this. CH3, CH2 twice CH3. All of them, they mean the same thing. Now for bond line structural formula, you are having something like this. Zigzag you make. Are you getting it? 4 carbons. First you make this, then we'll proceed further. Yes, are we done writing it, everybody? Now the thing is, suppose if I go for third example here, suppose if I go for C4H8, right? And let us say I have but1ene. In that case, what I'm going to do is, if at all I have to write down the expanded structural formula, this is going to be like this, 1ene. Only make 4 bonds here for particular carbon. What is going to be condensed structural formula? It is going to be CH3, CH2, CH double bond, CH2. What about bond line structural formula? There are 4 atoms. You can write like this, double bond. Now you must understand the bond angle here is 120 degree and here it was for sp3 it is 109.5 degree. So difference of 10 degree doesn't make much, much of difference is not there. So basically because of that, you still can have a zigzag here and placing the double bond either here or else below. Getting it? You can see for yourself. Suppose I show a molecule here, like this you are able to see. So is it having zigzag? If you remove this hydrogens, are you able to see this zigzag? And basically it is tetrahedral. 1 carbon attached to 4 different groups. So it is tetrahedral, right? So because of that only we are drawing zigzag. There is a significance of it. We don't draw just like, okay, we like this diagram, okay, in zigzag fashion. So let us draw it. Getting it? Now, if at all, I have a double bond like this. You're able to see a double bond? Double bond. Now in this case, are you able to see a double bond here, which I am showing by my finger here? Now the thing is, even like this, it is able to say, you are able to see the zigzag. I've just shown connected like 3 atoms, right? More than that also, it will proceed in zigzag manner only for double bond. Now, let us go for, suppose if at all it is but2-ine, then you can simply draw like this. I'm not drawing it. You can simply draw it like this, but2-ine. But2-ene, sorry, not ine, right? Now, suppose if at all I'm having C4H6. The thing is, it is butine. Now, the thing is, it could be but1-ine and it could be but2-ine also. Now the thing is, I'm going to simply draw its condensed structural formula and bond line structural formula, right? So for condensed, are you going to get this is CH3, CH, C triple bond CH. This is CH2. In this case, it is going to be CH3, C triple bond C, CH3. It is but2-ine. Now the thing is, when you draw its bond line structural formula, so you must understand this is 180 degree. And when we are drawing the zigzag, it is basically, it is telling you that tetrahedral is 109.5 degree. So between that, approximately if I take that as 109 as 110, suppose, and for simplicity's sake, for comparison, and you are having 180 degree here. So there is a difference of 70 degree, which is too huge as compared to, sp2 and sp3, which was just 10 degree difference. Are we getting it? So because of that, what we are going to have is basically, I need to keep it linear. Either I can keep it like this. And this is telling me one carbon here, one carbon here. Now, next to this triple bond, till one carbon, I need to keep it straight. And then only I can make like this. Or else, I could also draw it like this, even if you feel like, you can draw like this. But the thing is, if at all you go on making like this, it is going to be totally wrong. These two are fine. Getting it? This line should not be, kind of made zigzag. Getting it? Similarly here, what I'm going to do, either I can write like this, or else straight line itself I can make it like this. This is telling you 2 carbon atoms and these are 2 carbon atoms. That's what is but2-ine. Is this clear to everyone? If you want to see, you can see like this. Here I am showing basically pent 1-ine. Are you able to see a triple bond like this? A triple bond. 2 pi bonds we are able to show here in the model, right? So are you able to see this is straight here, linear, up to 2 atoms and one more next to it. You cannot make it zigzag like this bent. And after that you are having the same zigzag pattern. Or else I could also show it like this, little bit tilted, like the way I have pointed it out. I hope this is clear to everyone. Clear? Is there any confusion here? Did we understand what we are drawing? Good. Please make a note of it, then we'll proceed further. Yes, are we done? Can we proceed further? Now suppose if at all I am giving you something like C4H9OH. Let us say I don't remember the number here. Basically it's going to be 4. Okay, fine. So the thing is, it is something like it is saturated compound but having OH here. So basically if at all I want to draw the bond line structural formula, so 4 carbon you have shown, right? So there are like 3, 4, 5, 6, 7 and here you can show this OH with a small, small this tentacle like thing, okay? But that is also telling you like with respect to sp3 hybridization only we are saying, right? Similarly, if at all I have to write down for acetone, it is going to be bond line structural formula. Condensed formula is this: CH3, C double bond O, CH3. That is the condensed structural formula. What about bond line structural formula? You're going to simply show it like this. Getting it? Now, in like if any heteroatom is there, you are supposed to show it. Getting it? Suppose I am having C3, or else let us say I am having something like now CH3, CH2, CHO, propanol. So basically, if at all I want to draw the bond line structural formula, it is going to be like this. Sometimes the examiner will be giving you like this, so it is understood that the hydrogen is here. Clear? And if at all I am writing something like this, right? Connected to nitrogen. So if at all I ask you to write down the formula of it, so it will be like N connected to CH3. This is one carbon, CH3. Two carbon containing compound, CH2, CH3. Here also two carbon containing. Getting it? CH2, CH3. So you should be able to read all those things here. Are we done? Can we proceed further? So other than hydrogen, if there is any heteroatom, we are going to basically show it. Just by, kind of a small extension over there. Now next, let us go for, we are still in all those points. So we are having homologous series. What is homologous series? Basically, we know that there are millions of compounds, right? And if we keep on studying each and every compound, it will be a very tedious work, right? So people wanted to simplify their work, and for that, what they did, they organized the similar compounds into one series. Only thing that they'll be similar in the sense their functional group is same. They show similar chemical properties. That means if at all I talk about alkenes, so all the alkenes were kept together. They have the same general formula. Their chemical properties, that means basically the characteristic reaction for that is electrophilic addition reaction. So it shows that. Okay. So it became easier to understand them, and their physical properties also, the successive members will show some kind of gradation. Because we know that if at all, suppose by a boiling point I'm talking about, so basically it depends on the van der Waals forces over there, right? So van der Waals forces will be more if molecular masses will be more, right? And molecular masses will increase when the atoms are increasing in number over there, right? So basically we are going to write down the definition of it. The series which consists of similar constituted compounds having same general formula, right? Having same general formula, similar chemical properties, show regular gradation in their physical properties, then the successive member will be differing by a CH2 group or else by 14 AMU mass. That's what is the specific or else kind of characteristic of this homologous series. The consecutive or successive members, differ by CH2 group or 14 AMU mass. Right? So first finish writing this, and for certain homologous series we are going to write down the formula. So if at all you are having alkanes, so for all the alkanes the general formula is basically CnH2n plus 2. For alkenes it is CnH2n. For alkynes it is CnH2n minus 2. Right? Here, whatever is the number of carbon atoms, double than that if you are having hydrogen, it is alkenes. 2 more than the double, it is alkanes. 2 less than the double, it is alkyne. Like the way we have the simple one. And but you must remember one thing. Here, n equal to 1 for the first member. For alkenes, it has to be 2 because the double bond, alkenes and alkynes both, because the double bond will be made between 2 carbon atoms. So sometimes, a question can also be asked like this. Write the second member or else third member of the alkene homologous series, right? So, and if at all we just remember this formula, then we'll be writing C3H6, and that will be wrong because that will be second member. If we have been asked about third member, so we must know n equal to 2 for the first member, n equal to 2 for the first member. Getting it? So the question could be easily asked. Do remember. Hopefully this is clear to all of you. For single bond, it's okay. N equal to 1 only because CH4 exists. But you cannot have your double and triple bond hanging like that without being connected to any other atoms. Finish writing about it, then we'll proceed further. Okay. So let us go for the next term, which is degree of carbon. And hopefully you people are following whatever is the kind of number. It might have changed in between, but you keep a track of it. Okay. So degree of carbon. What is the degree of carbon? Basically, the number of carbon atoms with which one particular carbon is attached. That basically defines its degree. Okay. So when it comes to primary carbon or 1 degree carbon, then you are having secondary carbon. Then you are having tertiary carbon. And then you are having quaternary carbon. Right? So primary carbon means it is only connected to one particular carbon. You are able to see this? Both of them, they are primary. They are connected to only one carbon. Secondary, one carbon connected to 2 other carbon. Tertiary, one carbon connected to 3 other carbon. Quaternary, I'm not showing the hydrogens purposely here. That is understood that each carbon will be tetrahedrally connected to them, or else you have like, okay, rest which is remaining is 3 here, 3 here, 3 here, 3 here. Getting it? So both of them, they are primary, just connected to one carbon. The number of carbon atoms with which it is connected. Yes, are we done writing about it? Now let us move towards degree of hydrogen. Degree of hydrogen will be same as the degree of carbon to which it is attached, right? Same as the degree of carbon to which it is attached. That's what is the degree of hydrogen. Suppose hydrogen is connected to a primary carbon, so its degree will be primary, 1 degree, right? So same as the degree of carbon to which it is attached. So basically, type of hydrogens, how many I will be having? Primary, secondary and tertiary hydrogen. Will I have 4-degree hydrogen? Will I have that? You will not have. Because 4-degree carbon doesn't have any space, or else it cannot form one more bond with hydrogen, right? So primary, this is primary, this is secondary, and this is tertiary. So suppose if I give you certain example, let us try to find out the number of primary, secondary and tertiary here. You just have to identify the number of primary carbon, secondary carbon, tertiary. And do we know one thing or not? With primary carbon, there will be like 3 primary hydrogens. With secondary carbon, there will be 2 secondary hydrogen. With 3-degree carbon, there will be only 1 3-degree hydrogen. That we must see. So basically, you just identify this is primary, this is primary, this is also primary because connected to only 1 carbon atom. Here it is 3-degree. Now, basically, how many primary hydrogens? 3 here, 3 here, 3 here. So 9 primary hydrogens. How many tertiary? Basically, there are only, how many are there? Only 1 tertiary hydrogens, right? Simple to identify. Here, this is 4-degree, primary, secondary, primary, secondary. This is secondary, primary, secondary. So you are having how many primary carbons? 4. So there are 4 primary carbons, right? So 1-degree carbon, there are 4. So basically, how many 1-degree hydrogens will be there? 4 into 3, 12. Each primary carbon will have 3 hydrogens attached. Similarly, how many 2-degree carbon I am having? That is also 4. And so 2-degree hydrogen is going to be 8 because each 2-degree carbon is going to have 2 hydrogens on it. Right? You're able to see this hydrogen, this hydrogen. That's what we mean. For 4-degree, you don't have any hydrogen, right? Now here, all of them, this is 2-degree, this is also 2-degree, this is also 2-degree. So 2-degree carbon, how many? 3. Okay. How many 2-degree hydrogens? It will be 6 because each 2-degree hydrogen, each 2-degree carbon will have 2 hydrogens. Now here again it is primary, 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 primary. This is tertiary, this is tertiary. So basically how many primary carbons? There are 4, right? So how many primary hydrogen? There are going to be 12. How many tertiary carbon? There are 2. So how many tertiary hydrogen? There are going to be 2 only. Is this clear to everyone? Simple thing. You just need to check how many number of carbon atoms with which one particular carbon is attached. That's how we define its degree. Write this down, then we'll proceed further. Yes, are we done writing? Now next we are having degree of alcohol or else alkyl halide. Right? So this is again going to be the same as the degree of carbon to which it is attached. That means alcohol, we come to know that it is because of this OH group. Alkyl halide means because of the halogen, fluoro, chloro, bromo, iodo, like that. Okay? So basically in this, same as the degree of carbon to which it is attached. So I'm going to give you a few examples, you identify them. Please identify the degree of the alcohol which I have written here. This is 2-degree carbon. To that it is attached, so it is a 2-degree alcohol. This is a 3-degree carbon, so this is going to be 3-degree alcohol because OH is connected to that. This is a primary carbon. It is OH is connected to the primary carbon, so we call this as primary alcohol. Similarly here, you are having 2 degrees. So this is 2-degree alkyl halide. I am writing in general. It is alkyl chloride as such. What about this? This is a 3-degree carbon. To that your bromine is attached. So it is 3-degree alkyl halide. I am writing in general. Hopefully people have understood this. Degree of nitrogen is somewhat different. Right? You won't be saying the degree of carbon to which it is attached. We'll be saying the number of carbon containing groups which are connected to one nitrogen. That is defining its degree. Okay. So the number of carbon containing groups attached to one nitrogen atom defines its degree. Everybody has written this 2 degree, 1 degree. Everybody has written this so that I can scroll it up. Let me know. Yeah, good. So suppose I say that type of, kind of degree of nitrogen. So in this I am having primary nitrogen, secondary and tertiary. In fact, you will come across this, amines and amides. There you will come across this degree. So now the thing is here, if at all I talk about CH3, CH2, NH2. So there is only one carbon containing group. Let me write down in this form. Suppose like this I write. So this is a primary one because there is only one entire this carbon containing group which is connected to this NH2. I can also write something like this. Now had it been the case that the previous definition was correct, that means here it is 2 degree. So I would have told this that this is basically 2 degree amine, but it is not 2 degree amine because you are having only one carbon containing group which is directly connected to NH2. So do you realize the difference now? Is this thing clear? We define it by the number of carbon containing group directly attached to this nitrogen, right? Now here, suppose I am writing NH like this. You are able to see there are 2 carbon containing group. I could have written like this, NH, 1 methyl, 1 ethyl. Getting it? In fact, in the cyclic form also I can have something like this. There are 2 carbon containing group, like that we will consider. For 3 degree, here suppose if I write like this. So there are 3 groups, carbon containing groups which are connected to one nitrogen. That's what is 3 degree. Clear? Please write this and then we'll proceed further. Yes, are we done writing with everybody? Understood also? So these are certain basic terminologies. Now let us go for classification of organic compounds. Classification of organic compounds. All these things are very basic, fundamental. Many of you might be knowing also. So only thing is when you are reading it again, please try to have the same kind of enthusiasm which you had when you were reading it for the first time. And that is only possible if you're, kind of focused enough, because it may be possible certain time, like previously we didn't study properly or else some misconception is there. So because of that, we might be making a silly mistake. So this time, make sure that you are focusing in such a way that you are not losing the marks on the silly things here, right? Now, when it comes to organic compounds are broadly classified into 2 categories. One is open chain compounds and the other one is closed chain or cyclic compounds. Now this open chain compounds are also known as aliphatic compounds. Right? Now in this case, this aliphatic compounds are basically categorized into two. One is saturated hydrocarbon, HC I am writing hydrocarbon, unsaturated hydrocarbon. In case of saturated hydrocarbon, you are having example as alkanes, and unsaturated hydrocarbon you are having alkenes and alkynes. Now when it comes to cyclic, again you are having two major type, alicyclic and aromatic. Now you must understand, when I talk about the term aliphatic means earlier days when the organic compounds were derived, so they were derived from the fats of the animals and plants. So because of that, it has got its name, right? Now here alicyclic means it is cyclic in nature, but its property is similar to the aliphatic compounds, right? So here again, you are having homocyclic and heterocyclic. Homocyclic, or else we call this as carbocyclic, or else we call this as isocyclic also. So best example is you can have like a ring. These are the example, and just few I have drawn. So in the ring you are having all carbon, all carbocyclic consisting of carbon. Heterocyclic, you can have some other atom here like this NH. You can have something like this heterocyclic. Okay. Now in case of aromatic, again aromatic is a different class of compound. So basically it is, we can say benzenoid and non-benzenoid. As such, the detailing of this we'll be doing it later on. As the name suggests, benzenoid means containing benzene like ring. You are having benzene which is aromatic. At present you just understand double bond, single bond, double bond like this. Otherwise there will be certain conditions on the basis of which you'll be declaring it to be aromatic or else non-aromatic. Then suppose you are having naphthalene. So these are few examples here. Naphthalene. Then non-benzenoid means they are not having benzene like ring, but still they are aromatic, right? So suppose if I show this pyridine, it is aromatic. This is pyrrole, which is again aromatic. So these are just few more examples which we have given. You can also have furan, right? So these are few examples. They are aromatic here. So make sure you are writing them, and I'll just kind of squeeze them. I'll try to put them in one frame or one slide if possible. So basically from this kind of classification also very simple question could be asked. Which of the following is a saturated hydrocarbon, which is unsaturated hydrocarbon, homocyclic, heterocyclic? So you must know the basic definitions, right? Please write this down, then we'll proceed further. And I've written just few example in all the cases. There are just few. There are few more examples there. Entire millions of molecules we cannot write here. Yes, are we done writing? If we are done, then we'll proceed further. Now, after knowing all these basic terminologies, we are going to go for this IUPAC naming. Okay. So let us go for IUPAC naming of organic compounds. So you must understand that the IUPAC name, it consists of what all things, right? So basically, normally when I say a word, so before that only we'll be using the prefix, and after that only we'll be using the suffix. So basically, IUPAC name also is also like that. Before word root, you will be using the prefix, and after word root, you will be using the suffix. So basically, it consists of 2-degree prefix plus 1-degree prefix plus word root plus 1-degree suffix plus 2-degree suffix. So P stands for prefix here, and WR stands for word root over here. S stands for suffix. Getting it? So before word root, and do remember we have to start with 2 and 1, right? So basically 2-degree prefix, what is the utility? What does it tell you? It gives you information about the substituents. Where are the substituents? That means what are the substituents? Where are they? So that information is communicated by this prefix. 1-degree prefix, it is going to distinguish between cyclic and acyclic compound. If it is cyclic, then only use this cyclo. Otherwise, you don't use. Word root, it is going to tell you about the number of carbon atoms which are present in the parent chain. 1-degree suffix, it is going to tell you about whether it is having kind of saturated or it is unsaturated. Means whether it is carbon single bond or else carbon double bond or else carbon triple bond is there. Secondary suffix, it is going to tell you about the functional group. Are we clear about this, everyone? So we are just going to write it quickly because all of these things you already know, right? So first one is word root. Now we must know that the general word root is alk. Okay. And then basically what it tells you, it tells about the number of carbon atoms present in the parent chain. Right? So number of carbon atoms, and accordingly we are having the word root. So let us write about them. So 1 carbon atom, it is basically meth. 2 carbon atom, it is basically eth. 3, in fact, let me just write down 1, 2, 3. So because I've already put the heading, prop. 4, it is bute. 5, it is pent. 6, it is hex. 7, it is hept. 8, it is oct. 9, it is non. 10, it is dec. And 11 and 12, undec, dodec, right? 11 is undec, 12 is dodec. More than this, it won't be asked to you. That is the reason I am not writing it further. Please write it and then we'll proceed. And once you are done, let me know. Okay. Now, let us proceed further. Secondary prefix. This is secondary. So basically, secondary prefix, it tells about substituents. So basically, there are certain groups which are always like acting as substituents, right? So basically, substituents and basically there are 2-degree prefix. So suppose I am having R, so it is going to be alkyl. That means methyl, ethyl, like that we are talking about. OR is going to be alkoxy. It is alk and oxy, right? Then you are having X, which is halo. So basically it is going to be like fluoro, chloro, bromo, iodo, like that. They always get this particular, they act as substituent only. NO2, you are having nitro. And then you are having NO, which is nitroso. And in this list, basically substituents, junior functional group will also come, but I'm not including them here. We'll be making a later on like a table about the seniority order of the functional group. So there itself we'll add, right? So that is the reason I've just written few of them here. Junior functional group, that means when there are more than one functional group, so one of like the senior most functional group is treated as a functional group, rest of them they become like substituents, right? So what will be their name, it all depend upon what is the functional group which we are talking about, right? Please write this. Yes, are we done writing about the substituents here? 2-degree prefix. Then next is primary prefix. So it distinguishes between what? Cyclic and acyclic compound. It distinguishes between cyclic and acyclic compounds. Use cyclo as primary prefix only for cyclic compounds. That means, suppose if I write something like this, I can also make a ring out of this. So this is propane, this is cyclopropane. So this, to distinguish between them. So this is propane and this is cyclopropane. Clear about it? So you have to use only if it is a cyclic compound. If it is not, don't write acyclic like that. Cyclo, right? Finish this, then after that we are going to write down 1-degree suffix. Now, when it comes to primary suffix, it gives information about type of linkage present between carbon, okay? Type of linkage present between carbon atoms. So for example, if at all I am writing here type of linkage, that means it is going to indirectly give you information whether it is a saturated compound or it is unsaturated compound. Okay. So primary suffix here and the general name. Type of linkage, if it is single bond itself, so primary suffix is going to be ane and the general name is alkane. Remember, we have written a general word root which was alk. So after word root only you have to use the suffix. So it will be alkane. Okay. Now similarly, if it is a double bond, we are going to write ene. So it is going to be alkene. Similarly, if at all it is a triple bond, I am going to write down ine. And here I am going to write down alkyne. Right? If at all I am having more than one double bond, it is going to be diene and accordingly it will be alkadiene. Right? But if at all I am having a single bond, this double bond as well as triple bond, so I am going to use ene. So this is going to be alkene. Right? Few more are there, but I'm not including it purposely because the thing is, when I'll be teaching you about alkene and alkyne naming, there it will be included. Is that fine with all of you? So write this, then we'll proceed further. Yes, are we done writing? Okay. Now, last but not the least in this case, we're having 2-degree suffix. So basically 2-degree suffix or else secondary suffix is going to give you information about the functional groups, right? So it tells about functional group. Fg is functional group, okay? So certain example I am giving you. For example, a functional group and its secondary suffix. So if at all I give you something like OH, so it is all. If it is CHO, then it is ul. If it is C double bond O, which is basically on, right? So like that it can be B. Getting it? If at all it is COH, it is going to be oic acid. So from these suffixes we'll come to know which functional group is there. Can we spare 10 more minutes? Is that okay? I hope nobody is feeling hungry. 10 more minutes, after that I'll leave you. Is that okay with all of you? Yeah, fine? Okay, good. Thank you. Two-degree suffix finished writing now. So I have just enlisted few of the functional group. There are more than that. Okay, and we'll be making all those functional group we are going to write down when we are going to make the table for seniority order of the functional group. Okay. Now let us go for Iupac naming of saturated hydrocarbons or alkanes, one and the same thing. IUPAC naming of saturated hydrocarbons or alkanes. HC is hydrocarbon, okay? Now for deciding parent chain, what we require, you need to see a few things here in sequence, okay? First thing is longest possible carbon chain, so maximum number of carbon atoms. If that also becomes same, then you go for maximum number of substituents. If that also becomes same, then what you go for? You go for lowest set of locants. If that also becomes same, then you go for alphabetic order. That means you try to understand like this. First of all, whatever is the molecule given to you, you try to see which is the longest possible carbon containing chain. It may be like you can get it like horizontally or else by some zigzag like that. You have to check from all the direction. Now suppose that if from either of the direction or all the possible directions you checked and you got the same number of carbon atoms, there are two chains which are like giving you a tie. So in that case, what you have to go for? The one which is having maximum number of substituents will become your parent chain or the principal chain, right? If that is also same, then the set of locants you have to go for. Set of locants means those like numbers which define the position of the substituents. That's what is a set of locant, right? So if at all I'm having somewhere 1, 2 and somewhere 2, 3, this is one set and this is another set. So basically which set I'll be preferring, you have to check by like one by one, and wherever you get the first point of difference, that means wherever you are getting the difference for the first time, and at that particular difference when you are getting, whichever set is having lower number, that should be preferred, right? Here in this case like this, I'm giving you a hypothetical idea. You'll apply this, okay? Suppose I'm giving you 1, 6, 2, 3. Now the thing is, here only itself you got 1 and 2. So this is the lower number. I'll prefer this set. Don't claim that ma'am next one is like smaller number, 6 is bigger. No. We said that wherever you get the first point of difference, during that time, whichever set is having lower number, that should be given preference. Don't go for the summation rule and all those stuff. Is this point clear to everyone? Is this point clear? Good. And if that is also same, you go for alphabetic order. The one which comes, only if you are getting the same set of locants from either side, then only you should give the same, kind of the one, the substituent which is coming earlier in the alphabetic order, that should be given preference. Are we getting this? So first write this, then I'll give you a few examples. In this, you have to select the parent chain. You just highlight actually which is the parent chain, then we'll see. And purposely, and see the thing is, here I have purposely not written hydrogen. It has to be understood. And purposely I'm writing like this. Did you identify the parent chain in this case? See, you need to very patiently check it, okay? The thing is, normally students have the habit of using the pen itself. It's better when you are doing the questions, you have pencils in your hand. right? So that you can erase it at least. Now, otherwise, pen again, you have to write down the entire molecule. In this case, are you able to see if you check like this 1, 2, 3, 4, 5, 6, 7 only? You check like this 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So basically, this is the longest possible carbon chain. Right? What about this? So how would I name this? We have identified the parent chain. This is the parent chain. Let us name it also. In this case, basically these are the two substituents, and what you are having basically they are propyl, right? You have like you remove hydrogen from there, propane, you remove one hydrogen, it becomes alkyl. Alkane, remove one hydrogen, it is alkyl. So basically I'll be able to number it like this 1, 2, 3, 4, 5, 6, 7, 8, 9. And numbering also what you should be able to get, the substituent should be getting the lowest possible number, right? So here I am having 5, 5 dipropyl nonane. 1, 2, 3, 4, 5, 6, 7, 8. Okay, fine. And I have to write down propyl, that is at 5th position. 2 propyl are there. So I cannot just write down 5, 5 and propyl there. I cannot even write 5 dash dipropyl nonane. That will also be wrong. So you have to give the entire address. That means entire information. You are having this as prefix. You are able to understand 2-degree prefix about the substituent. It's not cyclic. So we are not writing 2-degree prefix. It asks you where are the substituents. That means what are the substituent? Where are that? You are able to see. Then we are after prefix, 2-degree prefix. What we are having is primary prefix will not come because it is not cyclic. And after that you are having word root. How many are there? 9 carbon atoms in the parent chain, so non. And all are single bonded, so nonane. Clear about this? So do remember between the two numbers you have to use a comma. Between a number and a name you have to use a hyphen. And do remember that for simple substituent like propyl, like methyl, ethyl like that, where there is no branching, this di, tri, tetra, it cannot be used for alphabetic order, right? So I'll write down these two things. Note. Substituents should get lowest possible number. Then what else you can have here is use comma to separate numbers, two numbers, okay? Then use hyphen between number and name. Then di, tri, tetra, etc. of simple substituents can't be used for alphabetic order. Right? Yes, I have given you this question here. So suppose if I go like this 1, 2, 3, 4, 5, 6, 7. Here, this is one possible chain. Right? I'll change the color to suppose pink here. Other possibility is 1, 2, 3, 4, 5, 6, 7. Now when I choose with the yellow one, what you are having is 7 carbons, but one substituent. Right? The 7 carbon chain, but one substituent. Now let me use something else. But if I go like this, you're able to see this chain? The blue one. It is having 1, 2, 3, 4, 5, 6, 7. 7 carbon, but how many substituents? There are 3 substituents. So basically when there is a tie, maximum number of carbon atoms in the parent chain are same. then how do you decide which is the parent chain? That chain which is having the maximum number of substituents. This one is the case, right? Now, how do you number it? You basically have to number in such a way that your substituents are getting the lowest possible number. That means you start from this end. You can easily check from this end. Now, if you are coming from this, the number, it will be starting at 4. Here, 1, 2, 3, 4, 5, 6, 7. So you are having methyl and you are having basically propyl. And whenever you are writing the substituents, make sure that you are writing them in the alphabetic order. That is important, right? Whatever is the irrespective of number which they are getting, you have to write them in the alphabetic order. So I'll write this one point. Write substituents in alphabetic order. Right? Now let us talk about this case. So basically what we are having is, we are having propyl, you are having methyl. Right? So we have to write down 2, 3 dimethyl 4 propyl heptane. Right? And I am not going to consider D here of the simple substituent. 2 more example can I take? Then few more example I'll give you in the next class, which you have to do. Can we take 2 more examples, simple ones only, so that you understand the meaning of all those things? Okay. Now next is, suppose I am having something like this. Here it is chloro, here it is bromo. Just 2 examples, last 2 examples. Right? Now in this case, how am I going to number this? Definitely this is the parent chain. I can number like this also, 1, 2, 3, 4, 5. In this case, I am getting 2, 3, 2 for chloro, 3 for bromo. But if at all I go in the reverse way, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Another set I am getting as 3 dash and 4 dash. Now the thing is, in the name you'll never write down as dash. This dash we are just using so that we can come to know, okay, this is the way we number it. So that we can distinguish, and we are able to avoid ourselves from getting confused. But we never write down dash there, right? Now, in this case, definitely, this is not the way we are going to go for, thinking that your bromine should be getting lower number. Entire set of the locant should be low, right? So that is how you are getting, you give the alphabetic order preference only when you are getting the same set of locant, right? Here you are not getting the same set of locant. Now from one direction you got 2 and 3, from other direction you got 3 and 4. 3 and 4 is bigger one. So here what you are going to write down is 3 bromo, 2 chloro, pentane. Able to realize what we are writing? 2-degree prefix. We are giving the information about the substituent. Where are they? What are they? And then word root and then the primary suffix. Here 1, 2, 3, 4. Then 2, 3 I am getting 2 for chloro, 3 for bromo. I can also go like this, 1 dash, 2 dash, 3 dash and 4 dash. This time I am getting 2 dash and 3 dash, 2 dash for bromo, 3 dash for chloro. I got the same set of locant. So remember, maximum number of carbon atoms. If that becomes same, then go for maximum number of substituent. If that also becomes same, then go for which one? Lowest set of locant. If that is also same, then you have to go for the one which is coming earlier in the alphabetic order. It should be getting lower number. So bromo comes. Now this time you can go for. So don't keep in mind that every time the one which is arriving earlier in the alphabetic order, it is going to have like more priority for getting lower number. Nothing like that. We are focusing only on the same set of locant. The moment we get the same set of locant, after that only we are saying we give preference to that particular substituent which is coming earlier in the alphabetic order. It is going to get lesser number, right? So this is going to be 2 bromo, 3-chlorobutane. Clear about this? Yes, is there any confusion to anyone in the naming portion? Is there any confusion to anyone? Up to this only we will study today, and in the next class when you are coming, make sure that you are revising whatever are the rules and everything I have taught you, because next class I am going to give you few questions which you have to do first. Is that okay? Please revise this. So I hope there is no confusion. Which one? 2-chloro. Which one? Which one, beta? See, the thing is, we have to write down in the alphabetic order. Realme, I think, what is your name? I don't know. Irrespective of the number which we are giving to the substituents, irrespective of that, we have to write down the substituents in the alphabetic order. That is the reason we are writing 3-bromo and 2-chloro. Getting it? Okay. Second one, I think this is the doubt for this person. Is this correct? In this case, see, the thing is, you are having, if at all you are having di, we are not using for alphabetic order, you are using L, M, N, O, P. I hope you remember your alphabets, right? So M will be coming earlier than P now. Now the thing is, if I select this chain, this is also 7-carbon chain, and there is only one substituent, this substituent. Yellow one you highlight, you understand this. If I select this as the parent chain, so whatever else is connected to this chain becomes a substituent. So because of that reason, there is one substituent. Did you understand this part, Vivo? The question which you've asked me, right? Now, when you count like this also, you are having 7-carbon chain, but you are having 3 substituents. You are able to see this substituent, this substituent, this substituent. So when there is a tie, that means from any direction when you are coming, definitely you have to check from all the possible directions for the longest possible chain. You cannot sit with only, I have checked in the linear fashion. You cannot do like that, right? So when you have selected from either of the directions and you are getting the same carbon atom parent chain, then you have to look for which is having more number of substituents. So in this curved chain, you are having this 1 substituent, 2 substituent, 3 substituent. So that is the reason it has become the parent chain. Are we clear about this? Right? Now the thing is, for numbering, I need to number from this end, because if I am coming from this end, the substituent numbering will be 4, 5, 6. I cannot go like that. Right? Getting it? So the thing is, here it is 2-methyl. So basically you are having 2,3 dimethyl. I am not considering di for naming. I am considering M. Then you are having 4-propyl. And how many? 7 are there. So heptane. I hope it is clear. Clear now? Yes. Realme, what is the example you wanted to understand? The last example. See, you understand here. There are 4 atoms, carbon atoms here. I could have gone like this way, 2, 3. So 2 for chloro, 3 for bromo. I am getting this set of locant. Now I can come like this also, 1 dash, 2 dash, 3 dash, 4 dash path. In that case, again I am getting 2 dash and 3 dash. So are you able to see same set of locants are there? Yes or no? It is there, na? So if it is there, in that case only, when you are getting the same set of locant, you are not compromising with the set of locants there. Here, why did we ignore? Because I was getting 3, 4 and 2, 3. Which one is lesser? 2, 3, na? So basically, here when I get the same set of locant, then after that only, whichever comes in the alphabetic order first, it is bromo first and then the chloro. So I am giving bromo preference because it comes earlier in the alphabetic order. That's why 2 bromo, 3 chloro. Clear? Good. So we'll see further than this in the next class, and hopefully you people are, kind of revising the things at the regular time. Okay? Yeah. Thank you and have a nice day.